What's going on, guys? It's Matthew Davis with Kingsman Homes. We're out here on a Saturday in beautiful Chapel Hill, Texas. It's also game day. That's why I got my game day gear on, gig 'em. But that's not what we're here to talk about. We're here to talk about this house in the Bluebonnet Ridge development, the things that we've done to promote health, durability, and comfort for whoever gets to buy this beautiful home. Starting out here on the very front porch, front to back, when we shot the elevations on this house, we noticed that we had roughly like a 5 to 6 foot drop from the back corner to the front corner. So then, rather than doing what you typically see in this market area, bringing in several loads of dirt, we took the opportunity to add an architectural element of this massive limestone block retaining wall. So what this is 4 foot by 2 foot wide solid limestone blocks. Then behind it, it's backfilled with gravel, and then we have 2 perforated drainage pipes that are pitched to slope out that way. And what you see with these green pipes sticking up is additional spots for us to add drainage, so that way no water stacking up against the backside of our retaining wall and trying to blow it out. So whenever it comes to durability of the home, water management's the main thing, and that water management starts with your site work. So what we did to combat these challenges and also add an architectural feature of it is do this beautiful retaining wall by Wade Construction. Nathan Wade with Wade Construction did a great job on it, and we're really appreciative of all the hard work. Moving on from the site work to the second part of the house that sees, or the property that sees the most amount of water, talking about the roof. So what we've done here is we did the zip system on the roof and the 4x8 sheets of the zip, and then we tape all the seams and we nail those zip panels off at a 6-inch on center pace with ring shank and screw shank nails to meet the fortified standard of roofing. Now, we're not doing this zip system in lieu of underlayment and shingles. We do the zip system for the event of one of those high wind occurrences where you have those shingles being lifted or being blown off, hail damage, any of those types of things. This is just a 3rd layer protection to keep water from entering the house. So by doing this, it's a good investment to make sure that your house stays protected from where it sees the second most amount of water, other than the ground around the property, is up on the roof. And that's our most high volatile area. In addition to doing the zip system, we did our MEP planning and prep for it to where we have 0 roof penetrations through the top of this roof. If you've ever experienced a roof leak, more often than not, it's wherever you have a penetration from either plumbing jack, AC jack, or roof vent. So here, the only roof penetration that we have is actually the chimney, which will then get a cap. So really, we have no penetrations through a roof throughout the field of this roof to just promote a truly durable and healthy, long-lasting roof system. Moving down from the roof and onto the soffit, we have what's called a sealed soffit, and the version that we've done is a assembly that I've coined the Midtex Monopoly framing, or a modified Monopoly framing. And the idea of it is essentially you have the continuous layer of air and water control from the roof down the fascia on the soffit back into your normal wall sheathing. So it's all one continuous air and water sealing done in a method that's conventional to traditional framing, just with one additional ingredient of adding that zip sheathing on the fascia and on the underside of the soffit to then continue that air and water sealing down and onto the face. So it's one continuous connection from the roof line all the way down to the foundation. And then down here at the foundation, where you see this several varieties of different colors, we use a few different products here. This blue is a product from Polyguard. And then I was worried about the blue being exposed and possibly being seen with our board and batten and lap siding where it goes all the way down to the foundation. So we actually use the zip system liquid flash here to make the connection because it's black. But then we continue that from where it meets the foundation and the underside of the sheathing up onto the face of it with this Polyguard product, because that's what we like to use for the most part. But I was just worried about that color being exposed possibly on the underside of that siding where the foundation meets the framing. So we take this, and this is a crucial area for air and water sealing. If you've ever put a blower door, even in the hot times of the year when your AC is running inside, if you reach underneath your lap siding, more likely than not, you'll feel cold air being pushed out from right here. So sealing this spot from air and water is a great way to improve the health and the durability of the house, because if you think about the terms of exposure, what's happening is this area right here, like the lower 2 feet of your house, is what's seeing the most water So sealing this connection, which is the most exposed edge of the OSB, and then we spot a few of the nails on the lower portion of the house to also help them be prevented from getting damaged by water. But a nice benefit of doing this method is it makes it impossible for bugs to get in there, because it's essentially a rubberized coating that makes the connection completely from the framing to the concrete. And if you ever had little kids after Halloween leave any candy or anything inside your house, that's where the bugs are coming in through. It's right there at this connection. For windows on this house, we use the Pella 250 series. This is a vinyl window that we've had excellent results with in the past, and we're continuing to have good results here. This is an Energy Star rated vinyl window. Again, it's the Pella 250 series, so it's a really good product that we like to work with. That's also pretty reasonably priced in terms of a quality window. Moving from the windows, in the areas that we're going to be doing stone on this house, we took the opportunity to use this PolyGuard term product. Essentially what it is a physical barrier to prevent any termites or literally pretty much any bug from coming up into your house. So you need some sort of capillary break in between your foundation and your brick. So we just took that opportunity to emphasize again, like your most exposed and critical connection of frame to concrete where we have a brick ledge, and we used this PolyGuard term product and applied it here and rolled it up the face. Behind this, we did, like in the other areas, we had the liquid flashing to make the connection, just because we figured we only have one chance at it, we might as well make sure it's good prior to applying this. But in theory, you could just use this for your air and water connection from here to here. And then at the top of it, we took the piece of the zip to terminate it here at the top. So this spot here behind our brick and stone, this lower portion is going to be rock solid in terms of keeping out bugs, keeping in air, and keeping out water. And the reason for not doing this PolyGuard term product everywhere around the house is because it's actually pretty UV sensitive. And I was worried about the exposure from where our lap siding ended over the slab, and I didn't want to see this bright red product that's also UV sensitive that can't handle, it'll deteriorate essentially over time with the sun hitting it. So everywhere we have a brick ledge is where we're able to utilize this product, and then elsewhere we just did what we do normally. But we did this behind this in addition to this. Kind of like that classy, cheesy builder saying a belt and suspenders approach, but wherever you have that brick ledge, that's where you're gonna have that water stacking up against the house the most. So we took that and then used this as our capillary break to make that connection from here to here, and then we just kind of double did it basically. An important part about the envelope of the home is establishing the envelope of the home. So you have to have complete separation and delineation of interior to exterior. So where that gets tricky is on the porch areas. So where you have a porch, you need to make sure you're taking your sheathing or establishing your envelope, however you're going to do that, all the way up to the roof line. And then the rest of it is going to be what's considered like a hot space. But wherever you have hot spaces, you need to make sure that you're venting that. So here on the porch, we'll have a ridge vent here, and then you can look on the other side of here. This soffit will also be vented. So all these hot spaces that are not inside the envelope, that still are under roof, will be getting vented. We have the same thing going on here in the garage. So you can see here, this soffit is open. So that will allow the air to flow up and under and out through the ridge vent that we're going to be putting on the outside of our envelope of our house. And if you're wondering, this right here is that port to charge the pest control system around the entire perimeter of the house. So it's convenient for your pest control company to just come up and charge it if you're still worried about those bugs getting trapped in between the wall and the siding. So this is the product that we're going to be using, the Keen Easy Fur. Everywhere we have siding, it's really foolish to have your siding just stuck directly against your sheathing, because that doesn't give your sheathing the opportunity to dry out. So you want to really space it off at least a 1/4 inch, preferably 3/8 of an inch, because that's the size that it takes for water to bead and run out. So I really like this product because of its ease of install. You can run it multi-directional without thinking about it. So everywhere behind our siding, we're gonna have this stapled to our sheathing, and then our siding nailed over the face of it. So if you can imagine that, we have this spacer essentially all the way around the house. And when it comes to the durability of the house, the reason why old homes last is because they could dry. New homes don't last as long because they don't have that ability to dry. So this gives us that ability to dry. So that way our sheathing and our structure will last a really long time, the siding will last a really long time, and even that paint will last longer on that siding because it has more of ability to dry in combination with it doesn't get as hot because it has airflow behind it. Moving on to the interior of the home. First and foremost, a clean job site or a clean house while it's in its production stage, still being built, is a healthy house. I mean, I'm sure everybody's experienced it or at least seen it. Walls with trash, beer cans, you name it, left in it. So a clean job site is ultimately a healthy job site. In here in our utility room, for a dual durability standpoint, we've gone ahead and brought in the main water line underground, because here in Texas we don't have a frost line. And then whenever we do have those rare freezing occasions, we isolated all our hose bibs on a separate water line. So when it comes time for winterization of your house, you just turn off this valve, open up your hose bibs around the outside, and it'll drain all the water completely out of that system because we've isolated it to be two separate components. Even on the outside, we're all sealed up to not let any bugs try to come in through there. We're not taking any chances. So this green dye that you're seeing is a borite treatment applied by our pest control contractor that basically makes it nasty for termites and other bugs to try to eat through. So that's sprayed on roughly the lower 2 foot of the entire house, not just the exterior, but also the interior. And moving on into this closet, this is where we stored, this is where we stored our low voltage package here. So all the home run wires, alarm system, and then this Smurf tube runs to the outside so your internet provider can then come fish their line to set your modem in this box here in this closet. So these are our windows that you can see how they're installed from the inside. Continuing with that theme of durability, protecting the raw edge of the OSB, because OSB is a pretty moisture sensitive product. Prior to our install, we actually taped the full opening, not just the sill pan, like what's required by code. We taped the full opening, left, right, top, bottom, and the corners we use the stretch tape to really get in those corners to fully protect the raw edge of the OSB and to continue that air control layer from the outside to the inside. And then after we set the window, what we like to do and what we've done here is use a caulking rather than the traditional expanding foam. So if you've ever built a house or been in the building industry for a little while, the first thing you'll notice whenever your sheetrockers show up to site is they essentially rip out all this foam here, which completely defeats the purpose of it. So we like to use a caulking because it provides a nice secondary back dam to the outside of the window if any moisture does get in there. Additionally, your sheetrockers don't start ripping that stuff off, so the seal actually stays as it's intended throughout the performance of the construction. So whenever we're framing this house, we frame everything on the advanced framing. What that means is 3-corner studs that you can insulate all the way to the outermost portion of the house rather than being filled up completely with the wood. And at the top, at the headers, we do what I call as a picture frame header or like a block out header, where you take those 2 structural components and push them to the outermost portion, being that we have a 2x6 wall on 24-inch centers. And then we can when we insulate, the insulator sprays and fills up that head cavity. So we have almost 3 inches of insulation at our window header compared to traditional framing where you have 0 insulation there. And then we take that one step further on our window sills. It's kind of actually an old adage or an old application of framing. If you've ever taken apart a house that was built in the 30s or 20s, you'll see that all the window sills are actually framed to be pitched. I guess during the Industrial Revolution, we sometime got away from that, but we're going back to it because windows do leak, they will leak, and when they do leak, you want to be able to get that water out. So to let gravity help us with getting that water out, we actually pitch all our window seals on a 5-degree bevel to the outside. So whenever that window leaks, it's going to leak pretty much in between where this frame is and the outside portion of it. And being that we back caulked it on a 5-degree bevel, that water will then just roll out and be able to escape from the window. So here's a good example of advanced framing, essentially in one isolated corner. We have our stud spacing on approximately 24-inch centers, and then we have a California corner or a 3-stud corner where you can insulate all the way back to the outermost portion of the house, so you don't have a dead area of uninsulated space from here that way. And then this stud, all it is it acts as a sheetrock nailer to give the sheetrockers some place to run the one sheet this way and the next one that way. And then the insulators can apply the insulation all the way back. The idea is to have less wood in the wall so you have more insulation so your home performs as it's intended. So with having a tight envelope, you need to be able to condition it. So a traditional AC system is single stage. What that means is basically every time your thermostat reads that the temperature is not what it's set to be, your AC system kicks on and runs at a full blast capacity, 100%. It doesn't have any ability to throttle up or down. And so you're not really getting the humidity removal that you want out of that system, and it's really not an efficient way of running, because imagine if every time you started your car, you just immediately took your foot and slammed it to the floor and only drove at maximum capacity at all times. So that's what a traditional AC system is. Here we have the exact opposite of that. We actually have an inverter-driven heat pump system, and what that can do is it has the ability to throttle all the way up and down the complete range, essentially from like 20% to 100%, depending on the need. So if the temperature setting is off like maybe 2 degrees, it's only going to run, maybe at 20%. And then if it has it way off somehow, then it has the ability to ramp up and run even higher. So whenever this AC system has the ability to meet the demand, it's going to be running less often also, with having a tight, well-insulated envelope. So our big concern there would be moisture removal. So to combat that, we have a freestanding, standalone dehumidifier in conjunction with their AC system. I say in conjunction, but they're totally two separated, isolated systems. On the wall, we'll have a thermostat and a humidistat. They do not interact with each other, because really the majority of the time with a nice, well-insulated, airtight house, the demand's not going to be on the AC system, but that humidity level will still rise from occupants, taking showers, you name it. So that humidity level starts to rise, and that's what causes those problems with mold and moisture. And it also is just uncomfortable to be in a humid environment. So that freestanding, standalone dehumidifier is what's going to be really running the majority of the time, keeping that humidity level at the desired rate that we want it to be at. So in conclusion, what does all this mean? I've talked about the various manufacturers that we're working with, different products, all these crazy technical terms, but really what does that boil down to and mean for your family? What it means is that we're building a house that's focused on being durable, healthy, and comfortable for its occupants. It's durable by keeping water out and letting water out. It's healthy because we're controlling all the things that we want to in terms of air quality, moisture, water management. And a nice byproduct of all that is that it's also energy efficient.